All right, welcome everyone. Thank you for joining us in this Open Security Summit mini session. So we're joined by Nicolas Boeckh, and we'll be discussing about IoT, pervasive vulnerability, and threat landscape and end users. All right, so we welcome everyone. Openness and respect should be observed, and everything in the summit is recorded and shared. So later, you can check our YouTube channel and um, the summit website for the materials afterwards. All right. Um, so to you, Nicholas.
Thanks. So, welcome everybody. As it was said, this is a talk about the Internet of Things, specifically three aspects of the Internet of Things. First of all, pervasive vulnerability. Second of all, the threat landscape of IoT, because that is a subject that is regularly discussed but rarely quantified, let's put it that way. And end users, which is yourself, myself, and everyone else in the world that uses an IoT device, a phone, a laptop, anything. Um, so to kind of start us off, I have a little bit of an introductory page and about the speaker kind of page. I'm Nicolas Boeckh, as was mentioned. I go by Atomic Nikos on the internet. It's a moniker I've been using for a few years now. I am a research assistant at the University of Geneva. I do a number of things on the side, specifically manage a community in information security, and I'm also a speaker at various events, such as this one. Um, so that's largely enough about me. I kind of want to start talking about the Internet of Things because although it's a topic we hear all the time, left and right, it's a topic which is a little bit complicated to define. The reason being that there are a lot of not conflicting, but separate definitions for it, right? So the Internet of Things, in its globality, right, has multiple formal definitions, which, if you kind of scale it down, goes to a network of devices that do something and that can communicate between each other. That is not a very specific definition, but it's a definition that everyone can more or less agree on. And that's, I guess, the closest we'll ever get to a definition everyone will agree on. Um, Furthering this kind of incomprehension, you have the fact that there's about 5, 10 to 50 billion devices that people consider to be a part of the Internet of Things. Uh, why such a big difference in numbers? Well, because not everyone has the same definition for IoT devices. So some people might not consider smartphones to be a part of this metric, or laptops or anything. Some people might just consider embedded devices to be a part of the Internet of Things. So this number, which, I mean, there's 8 billion people on the planet. So this is about the same number of people on the planet to 5 to 6 times the number of people on the planet. It's not a very small difference. But this difference, I guess, is kind of what symbolizes one of the main problems with IoT. Because beyond smartphones and laptops, you also have industrial control systems, you have routers, you have e-healthcare devices, you have cars. All of those things can be considered part of the Internet of Things. And the domains that are affected are, well, large. I mentioned e-healthcare, so think defibrillators that can be used to shock someone from a distance, or that measure your cardiac rhythm and send them to some type of a data collection server, something like that. To various things about automation, factories could potentially have IoT devices that, I don't know, build a car. Agriculture, a lot of new processes in agriculture use IoT and embedded systems to measure productivity, measure the best path, measure where a tractor has gone through, etc. Or just measure the humidity in a certain area of, let's say, a greenhouse. All of these things can be a part of the Internet of Things. So it's a little bit of a well, not complicated, but at least a broad topic. So one of the counterpoints, I guess, of the Internet of Things, and the fact that it's such a broad topic, is that it has a large amount of avenues to get to it. I say avenues, but yeah. You have multiple architectures that are supported. Uh, you could be running it on, well, smartphones are all more or less Linux architecture or iOS architecture, or the new when you go into laptops, you have x64, x32, M1, etc. All of these things, if you consider those things IoT devices, are different architectures. You also have ESP32s, etc., which are, let's say, more chip-based architectures. Well, they're all chip-based architectures. Smaller devices, let's say small boards with small microprocessors, etc. And the fact that there's so many architectures is already a bad thing. I say bad, but it gets worse. You have many languages, let's say programming languages, right, that have some support to become a program that can be embedded. I say it in this direction, in this sense, because that's to make you feel the problem. Let's put it that way. For example, your main Arduino board will probably have some C code, but you could also be using, let's say, Cylon.js, which is a JavaScript framework for IoT. And you're like, okay, that already sounds horrible enough, depending on how much you like or dislike JavaScript. Hint, a lot of people dislike it. But you could also have Python code that is embedded, etc. So it's already getting a little bit more complicated. And the thing is that there's a ton of manufacturers out there. If you go into the more, let's say, bootleg IoT, things that come off of, let's say, AliExpress, where you have 50 brands that have the same device, seemingly, they aren't necessarily manufacturers. They're vendors, right? So there's a little bit of a difference there. But there's still many manufacturers. A device that is manufactured by one company could have its boards used in devices that are sold by many companies. But yeah, so we'll kind of see how all of these manufacturers kind of factor in at some point in the threat landscape. So I kind of like to use this kind of meme poster to show you a little bit the breadth, because I mean, yeah, IoT is a jungle in of itself. So, now that this introduction has lasted much too long, I kind of wanted to go over what we are going to be talking about. So, if you saw the title, right, step one is going to be pervasive vulnerability. We'll be talking about how the Internet of Things is a vulnerable environment. Then we'll be going into the threat landscape, and that is the term I'll be defining then. But a shorter definition is to basically see all of the threats that exist or that can affect the Internet of Things. And we'll be going into specifics. And then it's yourself, myself, and everyone else, the end users. All of this will kind of bridge onto a small conclusion that will hopefully round everything out. So, pervasive vulnerability. Just for reference, all your toasters belong to us. I use toasters as an example. Because there is a joke, a main joke that is the joke between tech enthusiasts versus tech developers, specifically in the realm of IoT. So let's say you have a tech enthusiast, has a smart home, automation left and right, etc., and they have a technical toaster, right? Toaster connected to the internet, they can, I don't know, do toast from halfway across the world. A tech developer most likely is going to have none of those things and is actually going to keep, let's say, a gun or at least a spark plug next to their only connected devices just to be able to shoot it just in case it does a wrong noise. Right? That's the main joke of IoT. So let's go into a history of vulnerabilities. And I say history in quotes because, let's put it bluntly, IoT doesn't exist since that long, as in the sense of deployed devices, deployed systems. We've had computers for a while now, but IoT devices that are out there and that are, let's say, more vulnerable and can be uh, more easily compromised, and also there being a greater number of them, isn't necessarily something that you know that has been abundant in the last decades. It kind of all starts more or less. There's been incidents before, but with Stuxnet. Stuxnet being, Iran centrifuges that get affected and that hinder specifically Iran's ability to, um, use their centrifuges in their alleged nuclear program. 2010. That's not that far ago. That's 12 years now. That's a pretty big effect of using an attack or IoT devices. A centrifuge that's connected to the internet would technically be an IoT device, but using an attack on one of these devices to hinder some kind of process. If we go a little bit further, Karna, 2012. It was a botnet that would infect various devices, approximately 420,000 devices back in 2012. That's a pretty big number. That had the idea to map the internet using IPv4 connections. Was the last time it was really attempted at such a large scale with a botnet, and especially with the Karna program, because specifically the developers considered it to become too complicated as time progressed, and as the adoption of IPv6 got a little bit more, let's say, uh, democratized, I guess. But as you can probably notice, we're still all using IPv4, so that might have been the wrong assessment. Next up is Linux Wi-Fi, 2014. It was a malware, specifically in the sense that it spread and infected hosts like it, but it wasn't necessarily malicious. What it was doing is when infecting devices, and it was attempting to patch them against other strains of malware, which is something we've seen happen in the wild, but it's one of the, let's say, first bigger types of, I call them cleric malware. That's my Dungeons and Dragons side. That has been kind of like indexed at a larger scale. If we go a little bit further, in 2015, Xcode Ghost, that's moving away from, let's say, more embedded systems and going to smartphones. Xcode being the software that iOS developers use to, develop applications for iPhones. Xcode Ghost was a form of malware that, let's say, was embedded into applications for iOS devices that came from compromised versions of Xcode. So let's say you were using a, not hacked, but some form of compromised version of Xcode, let's say one that is not distributed by Apple. You had the possibility of, let's say, getting this malware to be then distributed in the applications that are built with that software. Gets a little bit more complicated. If we move a little bit further, there's a name that you might notice if you've heard anything about IoT malware in the last 5 years, Mirai. In very simple terms, it's a botnet that infects cameras, routers, and a range of other devices, right? And this botnet can be used for various other purposes. Has been purposed multiple times for DDoS attacks, of distributed denial of service attacks, and other types of attacks. If we go a little bit further, Gmail, 2016 as well, still active, is a worm that we don't necessarily know if it's malicious or not. It's potentially, it's already, let me rephrase that. It's a malware, a worm specifically, that acts a little bit like Linux Wi-Fi, in the sense that it does patch certain things, but there is no fully decrypted version of it that enables us to find necessarily everything it does. So it's potentially non-malicious. Brickerbot 2017 connects to any type of IoT device it can and bricks it. Applies a mistaken firmware patch or a bad one and just bricks it. That's not a good thing because it just renders entire networks of embedded devices totally worthless, and it's a pain to flash tens of thousands of IoT devices. So there's that. Moving on. Unity Miner. 2021, we are getting into the future. Unity Miner, you might notice it from the name, has the word miner in it. Mines cryptocurrency on devices. That's pretty much all there is to it. So yeah, that's pretty much the history of, let's say, the greater forms of vulnerabilities that have been exploited in the past. So let's kind of see where those vulnerabilities could affect, or what domains those vulnerabilities could affect. Just a small subset, but it's just to give you an idea. For example, home automation. You do have a range of IoT-enabled devices in the home, specifically thermostats, potentially ovens, your shutters, so to keep out the light, right? Your doorbell camera, your door lock, air conditioning, a fireplace, lights, anything could potentially be IoT connected. Toasters, as I mentioned earlier as well. So yeah, that is already a range of devices that could be compromised. Surveillance systems as well. Home CCTV could be affected, or at least they are a part of this home automation category, potentially. Physical security is the surveillance and security of vulnerable buildings. For example, data centers, company headquarters, shops, anything. Potentially also your own home could be counted as physical security. And all of this category contains various measures, such as we mentioned, surveillance cameras, tourniquets, so those big metal doors with a thing that only goes one way, right? Badge readers, so if you have RFID badges to get into you and out of your workplace. Various access control policies, so that would be more as a side effect of your badge readers. You could also have biometric readers. All those kinds of things kind of are counted inside of physical security. And a lot of devices are in there because they're, let's be honest, you are going to have more devices to perform the surveillance and the control and access to a company headquarters than you're going to have for home. And let's be honest, there are a lot of company buildings in the world. Moving on, environment control. Not in the sense of, knowing exactly what's going on in your environment, but more in the sense of knowing what's going on in your environment. Not the environment in the sense of what is happening, but the environment in the sense of what is affecting you. Specifically, sensors that can detect carbon monoxide, carbon dioxide, ozone levels, greenhouse gases, water pollutants, all these things. A lot of devices are out there to monitor these things. Specifically, there was one a few months ago that was mentioned where they would be putting devices in the sewers to potentially detect areas where COVID was more rampant by performing analyses of, well, let's be honest, let's use the words, shit that was flowing through the sewers. And that is an application for it. In the industrial world, you could use IoT devices to control, observe, and report on, well, via a distributed control system. So everything from, let's say, factory arms, quality control and safety mechanisms, operator direction, so let's say a remote control, remote or something, a safety sensor on a crane that it, picks up a big box and it won't drop it on some someone, if it detects someone, things like that. Um, so yeah, those are a little bit more the industrial side of things. There is a field that people like to talk about as a joke, but aren't really a joke, which is teledildonics. So basically anything that is, um, well, yeah, it's things that can be used in, let's say, sexual life, and they are usually intimately connected to individuals' body parts. I'm not going to go into too much imagery. This image is already imagery enough, I guess. The thing is, yeah, usually allows, or some of them allow a partner or someone on the other end of the world to control aspects of someone's, let's say, sexual life, such as locking, stimulation, etc. And if no, no kink shaming, but if you do that, you really want it to not be influenced by a third-party actor. Let me just put it that way. Moving on. Medical devices. Medical devices can be anything that monitor patient situation to potentially performs actions on a patient. For example, you could have a device that monitors your, let's say, glucose levels if you're diabetic, for example, and that sends this information to a control server that is then going to adjust how many EpiPens you're going to get per year, or if you're going to go into the dystopian version of it, how much your health insurance is going to bill you next month, because at the end, mostly everything is about money. So yeah. And the usual suspects in medical IoT would be sleep monitors, vital sign monitors, temperature monitoring, so internal temperature, right? Insulin pumps, pacemakers, things like that. So, breaches. Um, in 2020, there were 639 million breaches of IoT devices. This number is from Kaspersky. Trust them if you will. Don't trust them if you don't want to. But this number does seem more or less accurate. The main targets in 2020 were Ring, Nortec, St. Jude Medical. So Ring had weak credentials on its electronic doorbells, allowing people that were sharing a network for various reasons, or that managed to penetrate the network to then be able to use the camera. Nortec is an access control system. So what people could do is they could harvest credentials, control the devices that device was controlling, such as doors and locks, and it could also have malware on it. So people could just install malware on an electronic lock, which is not genial. St. Jude Medical had implantable cardiac devices. So when I mentioned pacemakers, it's not necessarily the same thing. It's not necessarily a pacemaker, but it does, well, a researcher found a vulnerability in it and then disclosed it. So yeah, in the first and second quarters of 2021, so that's the first semester, there were 1.51 billion breaches. So that's basically in the half year 2 to 3 times the amount of breaches that were in the previous full year. So it's getting worse. This image right now is an example of, let's say, Android malware, or at least one of the, not indicators of compromise, but potential indicators of compromise of a device by Android malware, where if an app asks you if it can send premium SMS messages, as in SMS messages that can cost, it's usually a sign of infection. Not necessarily, but it can be. So yeah, moving on to the threat landscape. Who exactly is out there? What type of infections are there? What type of manufacturers are the more frequently infected? if you are developing an IoT device or are using an IoT device and integrating them into your ecosystem, what are the risks that you should know? What potential actors are you going to encounter? And also, in terms of monitoring, well, in terms of monitoring, what type of indicators of compromise are you going to need to uh, keep in mind when you're going to perform assessments on your ecosystem, um, which I then quantified by, who is after my toaster. Um, there's one major problem when it comes to the Internet of Things and threat intelligence, or more specifically, identifying the threat landscape, is there is no actual definite source for information on IoT vulnerability. There's a number of separate sources. Um, one of these sources is the NIST Vulnerability Database, so NVD. You have MITRE, you have various database projects left and right, but there is no dedicated and universal source for IoT vulnerabilities. And that's a problem. You're going to find a number of CVEs, common vulnerability and exposures. You're going to find some things that are not even in a CVE database. And that is a problem. So I kind of wanted to show you a real data. And when I was looking for this real data, I was like, damn it, there is no universal data. So I went to investing. The VAR IoT project, it's a European project that aims to gather data, indicators of compromise, potential vulnerabilities, exposed devices all over the world. And that then gives you a very nice daily open data set, which has the downside of potentially being incomplete, because the IPs that are scanning could be potentially blocked by any type of service. Could be detected by a firewall, could be blocked by an ISP, could be well, you can only scan so many things in a day before you run out of processing power and out of time. So yeah, data can be incomplete. It's probably very incomplete. We don't know. So yeah. When I was talking about the fact that the number of breaches was increasing, yeah, this is the number of infected devices detected by day and which strain of infection was detected. So there can be duplicates in this line, potentially devices that are infected by two different strains, but it's already a pretty good indication. This is Android.Hummer. It's one of the more frequent forms of, well, strains of malware that is detected. This is Android Backdoor.Prismas, also malware, actually adware, but we'll get into that. And this is Mirai. So Mirai, which a lot of people are making a lot of noise about, is a very small subset of this data set. Now, I say small, but you might notice the indication of scale up here. Yeah, that's in terms of hundreds of thousands of devices, just so we get the scale right. So that's already a lot. Moving on, though, you'll also notice that this is data between May 2021 and December 2021. It's not necessarily a lot of time, but it gives us enough data to notice trends, such as, for example, the number of infected devices going down. That could be, as I mentioned, a fact that the scans are detected or blocked or any other type of things. For a device to be infected, the device needs to be exposed to the internet, but it could also be infected through a third party, or let's say another device on your network that itself is exposed, but your own device is not. So these numbers might actually be much lower than um, the actual number of devices that we can see in the world. What I am going to tell you is that there are 86 strains of not malware, but various types of infections that are detected. And so all of this data is sourced from of our IoT project. I did the infographics, they provided the data, which is fun because it's open data. So if we kind of go into which infections were detected, I did say we were getting a little bit more into, let's say, specifics. These are the values per day of detected infections. That already sounds horrible. Like almost 500,000 infections detected daily, potentially duplicates, very probably duplicates of Android Hummer. What is Android Hummer? Well, Android Hummer is a malware that will root your phone and will install applications, potentially pornographic content, and will serve you with a ton of pop-up ads. Doesn't sound cool? Is not cool. You'd probably notice if you were infected. But getting rid of it, since it roots your phone, is a problem. Moving on, Android Backdoor Prismas is a Trojan and spyware. It usually gets delivered somehow, but its main, let's say, the main thing it does is it sends a lot of data via SMS to some form of command and control server, or let's say device that can accept SMSs. And it captures your keyboard inputs, so potentially passwords, right, and system info. And it just sends that over the wire. Okay, it also has another name, depending on which database you're looking into, trojan-sms.androidos.prismies. So yeah. Mirai, as I said earlier, it's a botnet. Android.rootnik, it's the same thing as Hummer, except it's apparently less efficient or hides better. It's roots your device, installs malware, installs adware, which potentially shows you pornographic content, etc. Right. Dark Silent is a Trojan. It's a Trojan which was delivered as a system application. Now, just if you manage to wrap your mind around that, an operating system vendor that was using a version of Android, specifically Wico, which is an ex-French, now Chinese company, was, delivered an update to their File Explorer app, which is an app that you'd be using if you're using a phone, potentially to view images, files, downloads, all that stuff. And what it would do is it would infect your phone and then consume a lot of bandwidth for, whatever purposes it was doing. And that lasted for about 3 years, and in 2017 or 2018, Wico pushed in, 2017 is when it appeared. 2018, 2019 is when they decided, when Wico was informed, and that they pushed an update to negate it, but it's still out there as we can see. So, that was the top 5. Last 5, Android You Pay, roots your phone, is spyware, installs malware, installs adware. It spreads by installing apps from third-party app stores, specifically, I don't have the name of the third-party app store in my head. It sends SMS messages, it sends various system info, such as access point names, etc., over to its command and control server. Right. QSnatch is a malware that targets network attack storage. So we're finally going away from phones and, let's say, more embedded IoT. We're going to NAS devices. And no one really knows how it works, legitimately. but the main idea is, or the main comprehension of it is that it affects firmware of NAS devices and gains access to the content and the credentials and all that. So yeah. Eighth is Telnet brute force. It's literally an open port which exposes a Telnet service in Linux devices. People can talk to it. People can compromise devices with it. Flubot, it's a Trojan. It performs overlay injection on a phone. It is basically a advanced phishing app in the sense that it will detect which service you're looking at, such as, let's say, Coinbase or whatever, or your banking app, and it'll display an overlay on top of it, and you'll enter your credentials, and it's going to farm those credentials and send them somewhere else. So it's more advanced phishing. You have MK-Eero, which is a Trojan which has which infects you after a delay, and that's already something horrible. So it's found on the Play Store, the legitimate Google Play Store, but it infects you after a delay, and it exists in a few game apps with weird permissions. So yeah, don't trust everything you install from trusted sources. I mentioned 86 strains were detected. This is the average number of strains detected by day on each scan. So you have the earlier days, which were a little bit between 30 and 40 strains. You have most of the time, oops, sorry, my bad, where you're between 60 and 70 strains detected. So that's already pretty good. Pretty horrible for your threat landscape because there's a lot of things willing to infect you in the world and a lot of different types of infections, but it's something to be aware of. IoT is extremely vulnerable. Moving on from what I just said, infections aren't the same thing as being vulnerable to an infection, which aren't the same thing as having an exposed device. Infection can be detected with an indicator of compromise, potentially. It means that the malware or whatever is already usually on your device or has been on your device. Vulnerability means that through scanning the version numbers, the very specific endpoints that may be accessible or not, and a number of other factors, potentially, your device may be vulnerable to a type of infection, potentially. And exposure is that you can ping it and that it's going to respond in some way, shape, or form, so that it can be seen on the internet. So with this small definition, which not necessarily entirely correct, but is good enough for our purposes, we'll kind of go into the various types and vendors that produce potentially vulnerable devices and exposed devices. So these are all the potentially vulnerable devices that have been scanned. So not a lot at the beginning, a lot at the end. These are all routers, and well, the scale is 50,000, so it's not a lot, but that's potential vulnerabilities. That's just the number of vulnerabilities. That's not the number of devices. So nice little difference there. These are conferencing systems, so things you'd find in, let's say, conference rooms, in companies, etc. These are VoIP systems, so everything you use to discuss with one another over the internet. Device management systems, systems that allow you to manage devices. So as I said, routers, about 15,000 potential vulnerabilities detected a day. That's a lot. Conferencing systems, about 7,000. VoIP, 6,500. Device management, 1,500. The rest is a little bit less. Video systems, PLCs, etc. So if you're going to look at something, look at this top four, because those are the ones where you might have the most vulnerabilities in your ecosystem. If you look by type, detected, you already see we're at another scale. We're in the hundreds of thousands. Blue is, again, once again, routers. Green is NAS devices. Purple is video systems. So yeah, a lot of routers are exposed to the internet. Who would have thought it? It makes sense when you think about it. NAS devices as well, video systems, a little bit less unless you consider home surveillance, etc., that people can access their home surveillance video systems from somewhere else. But yeah, all of these types of devices are detected daily. And they're not necessarily vulnerable, but they're, let's say, pingable. So if they magically start exhibiting a vulnerability or vulnerability is found, then a lot of those things may be vulnerable. So I think we kind of went over what is the top three. Routers, NAS, so network attached storage, video systems, embedded systems. We weren't able to see that on the graph, but they're there. It's mainly everything that is industrial control systems, temperature, etc. Wireless access points, because it makes sense that if you can see routers, you could maybe able to see wireless access points. So yeah, moving on to potentially vulnerable devices. This isn't the number of vulnerabilities. This is the number of devices which are potentially vulnerable. If we look at this, we have by vendor, Cisco, which is the main one, that's seemingly vulnerable. Moxa, which I don't know what they do, but they are apparently on this list. Netgear and Asus. All of these produce routers, actually. Moxa being a little bit more recent on the field. So yeah, a lot of these produce NAS devices or routers, Siemens, TP-Link, D-Link, Asus, Cisco produce routers. So you might know, see between all of our graphs, which devices are the most frequently vulnerable. So yeah, if we look by vendor, going a little bit faster here, Cisco is there. Huawei is also there. They also provide routers. Sagemcom, I don't know what they provide, but they are also quite exposed to the internet. So it might also be routers. So yeah. What I just mentioned. Moving on, and I'll try to, have the time to finish this, to the end users, which is yourself, myself, everyone else. We have one expectation, is that if we buy something for more expensive, it'll be safer. Companies that generate more revenue produce less vulnerable devices, or have a better security program, or anything. Well, no. If we look at this and we base our previous graphs based on the annual revenue and the number of companies in that, you'll see that this area here, right here, yeah, a lot of companies and a lot of vulnerabilities. Now, I'm not convinced by this graph, so I kind of removed Cisco from the equation, and we now get a, let's say, more palatable graph. Small companies, not that much revenue, not that much vulnerabilities actually. The main area where you'll get vulnerabilities is between 0.1 billion and $1 billion dollars in revenue, and you still get a lot of vulnerable devices, as in by type of by model of device, in the upper clusters of revenue. So yeah, between 3,000 and 4,000 potentially vulnerable device models out there in these upper echelons. So yeah, paying more doesn't necessarily guarantee you better security. That's one of the main conclusions. IoT isn't going anywhere. It might not be on the Gartner hype cycle anymore. This is 2015. It was on the Gartner hype cycle until 2018. It's a pretty good indicator of where things are going. People might consider the Internet of Things as too useful to go away, but other people are saying that it's doomed. Read an article on Forbes saying it's not ready for prime time. Another article which said, can it be saved by blockchain? The answer to all this is no. IoT isn't too useful. It's very useful for the context you're going to use them for. It's doomed. Not necessarily. It depends on how you use it. not ready for prime time. A lot of companies would disagree with you because a lot of security systems and all those things are already using IoT devices, thermostat, all of those things, smart heating, the temperature of your bathroom, all of those things, it's already there. It's already prime time material. Can it be saved by blockchain? No. Recent improvements, yep. In terms of how it affects users, is that there's a lot of recommendations that have been put out by the European Union Cybersecurity Agency, ENISA, the NSA, National Security Agency, Cybersecurity Infrastructure and Security Agency in the US as well. They've all published a lot of recommendations for IoT devices, and specifically their security. Brilliant. There's a lot of recent ISO and IEC standards, such as ISO IEC 21823-2 2020, which is the interoperability of IoT systems, specifically on the interoperability for transport, which has a big section about security of data being exported. Very important. You also have legal bills. The House of Representatives Bill 1668 was the IoT Cybersecurity Improvement Act of 2020, where they at least put guidelines for devices in federal buildings, which force device manufacturers to get on another level. In the UK, you have the PSTI bill. That's a very recent one, Product Security and Telecommunications Infrastructure Bill, which goes into detail about, hey, let's not have default passwords, and let's make it illegal. And that way, most of our consumers will be safer. So it's kind of getting there, but the problem is if we use the ENISA recommendations just as a baseline, the ENISA recommendations is 103 pages of content. 7% of those are security measures. So about 7 pages. That's not a lot. So yeah, 7 interesting pages, quote unquote. And in those 7 interesting pages, you have 80 recommendations in 3 categories. So it's more a recommendation than telling you how to do that. So that's important to keep in mind. So yeah, the conclusions mainly is that IoT is, well, very vulnerable. The threat landscape is chaotic and, let's put it this way, unmeasurable in any way that is consistent or easy or, well, to be honest, usable or actionable. And in terms of the end users, the end users are still being left out of the equation for the moment because, like many other domains, IoT is considered by companies as a way to make a quick buck by selling something that is attractive, but that isn't necessarily usable for a certain number of years. This is changing slowly, but too slowly. So yeah. If you want to use these slides, they'll be on this GitHub. It's CC by SA, so just use it, just attribute it. And yeah, if you have any questions, I do exist on Discord. I do exist on Twitter. Yeah, on LinkedIn as well. Link was earlier on in the presentation. And that's pretty much it. So yeah, if you have any questions, I think we still have 5 minutes to dedicate to that. And yeah. Also check the Slack to see if there's questions there. How can I do this? There we go. No questions on the Slack. Right. thank you to you too for attending. Right. Well,
Right. Awesome. Thank you. So we encourage everybody to ask any questions. So if you have any question in there, you can just type in our uh, chat. So yeah, you're welcome. Oh, okay. So I think I'm going to unmute. So people, let me unmute people. Oh, no. So if you have any questions, you can unmute yourself now.
I don't think it looks like we've got any other questions. So I think we can stop the recording now. Thank you.